Thanks a lot for coming to my talk, Things I Wish I Knew When I Started Testing Spring Boot Applications. I want to start my talk right off with my not so effective journey to testing Java applications, and maybe some of you can relate. So I studied business information technology 10 years back, and quite late into the studies we had a group project where we had to develop a small game, and as part of the requirements for this group assignment we had to provide some tests. So none of us knew how to write tests, and as it always goes, we were super eager to develop the game, and one day before submitting our final code, we rechecked all the requirements and recognized we had no tests. So none of us was aware how to write tests, and in the end, what we ended up throwing JUnit, Mockito, and everything we found on the internet to our project, added something to source test Java to at least make this requirement pass. And yeah, the tests were meaningless. We were just invoking some of our classes. Our assertion didn't make sense. But in the end, we still made this class as the instructor just wanted to see something in source test Java. So that made me kind of questioning. At university, we learn data structures. We learn how to normalize tables with relational databases. We learn about algorithms, but at least for me, nobody taught us how to do effective testing for our applications. And then we start as greenhorn developers in project and have no idea on how to do it. The same then applied for me when I got my first job. I was super excited to now join a team, become a professional Java developer. After 2 weeks of setting up the machine, getting to know the domain, getting to know my colleagues, I finally could pick a task at the daily stand-up, pick a Jira ticket, something small to implement. You're new, you want to prove yourself to show that you are capable of developing something. So I picked something, went into kind of 1 week of isolating myself to try to implement the feature I picked. And then when I was finally done with the feature, I raised a pull request, was super proud, and wanted to show the lead developer that I was able to implement the feature. And the feedback I got immediately after submitting the pull request was something like this. Then I looked back at the Jira ticket. I couldn't find any statement about adding tests to it. So again, I was just aware I need to add the feature, nothing about tests. So again, I asked the lead developer how to write tests. He also wasn't sure. He said, yeah, just look at the other tests and copy-paste stuff and try to make the code coverage in Jenkins work. That's what we do here. I did that, and after 1 week of figuring out, could finally integrate the change and was happy to at least develop something, but really completely unsure when it comes to testing. So that's why at least I want to give you a first introduction or cover at least the fundamentals when it comes to testing Spring Boot applications, what Spring Boot offers when it comes to testing. So the goals for this talk are to lay somewhat a foundation for your Spring Boot testing success. I want to give you an introduction to Spring Boot's excellent test support, because I think the team made a great effort to provide a lot of features, a lot of tooling around testing, so we as a developer don't have a hard time trying to figure out how to test our applications. I want to showcase a mix of best practices and early pitfalls, and convince you a little bit that testing shouldn't be an afterthought, because after I found out how all the testing tools work, how and why to test, I can really say testing can be joyful if you understand your tools and know how to test your applications. So, coming to the agenda of this talk, we just covered the introduction for this talk. Next follows the things I wish I knew when I started testing Spring Boot applications. So as a short disclaimer, this talk is beginner friendly. I also gave this talk at some point in time and got the feedback that some of the stuff I'm covering can be read in the documentation, but I guess most of the stuff we are talking about can be read in the documentation. And who reads documentation, especially when it comes to testing? So at least with this small 45 minutes I now have, I want to give you snackable units of knowledge that you can use for your Spring Boot testing success. So we will cover 4 things I wish I knew when I started testing Spring Boot applications. The first one is the testing Swiss Army knife. Next follows @Spring Boot test isn't always your friend. After that, we will cover a bit slicing. And last but not least, a more practical hint is the JUnit 4 versus JUnit 5 pitfall. In the end, I will give you some points on where you can go next, and if there is time, I want to conclude this talk and also have some time for Q&A. Some words about myself. So I'm Philipp. I'm a freelance IT consultant from Berlin, Germany. Apart from helping clients become better at testing and become more productive while having a covering test suite, I'm also creating quite some content on specifically testing Spring Boot applications on my blog and on YouTube. I have co-authored a book called Stratospheric: From Zero to Production with Spring Boot and AWS. So if you're working with this tech stack, check it out. We cover everything from creating a continuous integration pipeline with using the AWS CDK to define the AWS cloud infrastructure resources with Java, up until the point to develop a real-world application while integrating most of the important AWS services. You will also find some social links here to connect afterwards. And without further ado, I want to start now with the first thing I wish I knew when I started testing Spring Boot applications. I personally call this the testing Swiss Army knife. And what I refer to this is the Spring Boot starter test. So as part of every project that we either start from start.spring.io or bootstrap within our IDE, we get this dependency pulled into our project. We can't even deselect it, so I think it was a great design decision from the team to make it part of every project that we use with Spring Boot. And under the hood, this small starter, we may not even recognize it when starting a project, or we scroll over it inside our big POM, brings us our basic testing foundation. If we take a closer look into the dependency that this Spring Boot starter pulls, so if we run a Maven dependency to check the transitive dependencies, we will see quite a lot of dependencies that gets pulled into our project. In the end, it's an opinionated testing toolbox that we can use from day one, so there are no religious discussions with our lead architect on which testing frameworks to use. There is no time needed to fiddle around with any plugins to make sure testing is working properly. With Spring Boot, it just works. The great thing also is that the testing libraries get consistently upgraded with upgrading Spring Boot. So the Spring Boot team manages these dependencies, and whenever we upgrade our Spring Boot project, these testing dependencies also get updated. Yes, and what I want to do next is cover each of these testing tools that are part of this testing Swiss Army knife that is part of our project from day one, quickly with a small cheat sheet. So one of the most important testing tools when it comes to writing tests with JUnit is JUnit 5. JUnit 5 is a core testing framework, and I would say the de facto standard currently when it comes to testing Java applications. It's a successor and rewrite of JUnit 4. Apart from this tiny @test annotation we put on our test method to let JUnit run the test method as a test, there's a whole bunch of features available with JUnit 5. So JUnit 5 comes with a rich extension model that is also heavily used in Spring and other libraries to integrate with this testing framework. There is test parallelization available, so just by changing some configuration properties, we can parallelize our tests and get faster feedback. There are dynamic tests and also parameterized tests and much more. So JUnit 5 really builds the foundation of our testing toolbox. What follows is Mockito. So Mockito is also transitively pulled into our project when including the Spring Boot starter test. Mockito is, I would also say, Java's de facto standard mocking library. With Mockito, we can mock collaborators of our class. So if we test a class that needs other classes to work, we can mock these classes, stop their behavior to test the different outcomes of our methods, and then finally also verify the interaction with our mocks. Apart from normal mocking, there's also deep stubs available. We can even now, with recent Mockito versions, mock final and static methods. All in all, I would say Mockito, at least what I see in project, is easy to learn but hard to master. When using it too much, our tests become brittle. But all in all, it's one of the testing tools we have at hand on our daily basis to write tests. Next is SRJ. So JUnit 5 that we saw also already comes with assertions, the traditional assert equals, but there are more assertion libraries pulled into our project when using the Spring Boot starter test. This one is SRJ. It provides a lot of matchers in a fluent and sentence-like style, apart from basic strings and primitive types, for example, for collection or temporals. We can even write our own assertions, so if we're having a big domain object that we want to write assertions for, we can come up with our own assertion to not have to replicate a lot of code. Apart from SRJ, there's also Hemcrest. So in the end, we have the choice of 3 assertion libraries we can use in our tests. What I follow as a best practice is at least to stick to 1 assertion library for a test, and if best also for the entire project, but taste is different and people start adding or using different assertion libraries for their projects. So the other one here is Hemcrest. It's quite similar when it comes to the syntax to SRJ. We also see some APIs within Spring Test that make use of Hemcrest, for example, mock MVC that we will see later on. So in the end, it doesn't hurt to also learn about this assertion library. And if you're coming from different programming languages, you might have also get in contact with Hemcrest, as it's also implemented for other programming languages. One of the more niche testing tools that not everybody might be aware of that gets pulled into our project is JSON assert. So this is quite helpful when we're working with JSON data structures. With JSON assert, we can compare entire JSON objects and check the quality. JSON assert comes with a strict and non-strict mode. The difference is if we run with a strict mode, all the attributes have to match, whereas in the non-strict mode, we are fine if just the expected attribute is part of the payload. So this can make sense if we verify the outcome of a REST API or some small processing unit inside our application that produces a JSON. And the last tool that I want to cover now that gets pulled out of the box, so what you saw here now gets included right from day one, and I refer to it as the testing Swiss Army knife, is JSON path. So this is a also small utility library that can help us test our JSON data structures. Using JSON path expressions, you can see one here at the bottom. For this given JSON object, we want to check the length of the tags array. And with a single line and this dollar expression, we can extract this information from any given JSON, any nested JSON data structure, and then use any assertion library to verify the result. So apart from pulling these dependencies to our project, there is more that gets done behind the scenes. So as already mentioned, Spring Boot is in the driver's seat. We don't have to take care of upgrading, maintaining, and also making sure that the testing libraries work together. All of this is done by Spring Boot, so by just upgrading our main Spring Boot version, we get a bump of all these libraries. There are even more libraries that are managed by Spring Boot, where the version is taken care by the team. Examples are Avatility, Selenium, or the mock web server. So if we're using one of these testing tools, we can omit the version as you see here in the dependency include, as this version number then gets pulled from the Spring Boot parent POM. We can also take the driver's seat if we want. So if we are running on a older Spring Boot version and want to, for example, make use of a recent Mockito version, we can override the Mockito versions. So there is no need to exclude a testing dependency from the Spring Boot starter test and then re-include it on our own. We only have to change a single property, and here in this example can upgrade Mockito to 4.9.0, and then Spring Boot will back off, and we are then in the driver's seat to manage the version of our testing libraries, similar to any other library that gets managed by Spring Boot for us. Going over to the next thing I wish I knew when I started testing Spring Boot applications. This will be a little bit more practical now. I call it @Spring Boot test isn't always your friend. Speaking of things that gets auto-generated for every new Spring Boot project, we can see, or most of you might have seen it if they start a new Spring Boot project, Spring Boot automatically generates a single test inside source test Java, which usually looks like this. It's annotated with @SpringBootTest and a single test method that is empty. The name of the test method already applies what this test is doing. It tries to load the context. So with @SpringBootTest, if we see on the right, this circle should represent a classic Spring Boot application. Each smaller circle here is a single Spring Bean inside our context. So we have a web layer, some controllers, some utility classes that are part of the entire Spring Boot context, some service classes, and also a data layer. When writing or when running this test, what Spring Boot will try to do, it will try to start the entire context for testing purposes and make sure that we can wire all the beans together and also all the properties that are necessary can be read, and we can write a proper integration test against our entire Spring Boot application context. And before going deeper into the pitfall, some more words about this annotation to understand its usage for an effective test suite. So as mentioned, it populates the entire application context. It's best suited for integration tests as all our beans are available in the context. When we talk about starting the entire context, we also shouldn't forget that for testing purposes, we then have to also provide all the surrounding infrastructure that our application depends upon. So usually a decent microservice today with Spring Boot connects to a database, does some network call over HTTP to fetch data from a remote service, maybe connects to a message queue or calls anything else in the internet. So whenever we use this annotation and start the entire context, we have to provide all of these infrastructure components for our testing purposes. There are two differences when using this annotation. So the first one is without any further configuration, just as we saw it before. This one, as some developer may think, does not start the Tomcat, so there is no Tomcat started locally. What gets auto-configured is a mocked servlet environment that we can interact with. So when using this annotation without any further configuration, there is no port locally, so we can't use any HTTP client to connect to our application. There is mock MVC, which we will see in a second, that can be then used to interact with it. If we want to start Tomcat to really then start the embedded servlet container, if we're using Tomcat, for example, we have to define the web environment to either a random port or a defined port. When it comes to tests, it usually makes sense to use the random port to have ephemeral ports that don't clash with any started application, and we can also start multiple contexts in parallel. And upon configuring the web environment, we then also get the web test client and the test REST template auto-configured for our tests that we can then inject and talk over real HTTP with our application. Or if necessary, inject the port that the Tomcat was started with @local server port. So the pitfall that now lies in this annotation, or that I'm seeing quite often, I refer to this as the Spring Boot test obsessions. So especially new developers see this annotation. It reads @SpringBootTest. So they assume they have to use it for all of their tests, which can be a bad practice. Because if they now want to test a single service, so the red service here that is marked, they want to write somehow a service and test all the branches of their implementation logic. They now have to find a way to mock the surrounding services. And they only know at Spring Boot test, so they start using this annotation and then use at mock bean for all the collaborators of their service. So with at mock bean, we simply replace a bean inside the application context with a mocked version of it, and can then use Mockito to stop the behavior and then test the different outcomes of our single service that we want to test. While using at Spring Boot test now brings a lot of downsides to our entire test suite, because what this now brings, if we would repeat this pattern for all of our services, we would end up with very different context setups. So behind the scenes, Spring Test is capable of caching an already started Spring context. So if the context configuration for a test is similar between two tests, Spring won't start the context again and simply pick out the context from the cache to run the single test, saving us a lot of time. If we apply this pattern and mock out now various beans of our service for all the different variations of the tests we want to have, we end up with tons of different context configurations. Because if for one context a service is mocked and in the other one a service is not mocked, Spring can't reuse the application context and then has to start an entire new context for the single class that we just want to test maybe a single formatting method. So this results in a lot of different application contexts being started, which in the end brings way slower feedback times, because at least any decent or bigger microservice takes some seconds to start, and all of this adds up and slows down our test suite, because each independent test, if we go with this approach and use at Spring Boot test for all our tests, ends up in quite slow builds and very bad feedback loops. So this is here an example what I just explained. If we would use at Spring Boot test to test a single service in isolation, we would have to fall back to this at mock bean annotation and then navigate through our entire context to mock the collaborators, resulting in a different context configuration. Spring won't be able to cache the context for testing purposes, then having to restart an entire Spring Boot context for all subsequent tests, slowing down our operation. So in here, the better approach would have been, if we want to, specifically if you want to test something really in isolation, we are not interested in starting the entire context. Starting the entire doesn't add doesn't add any benefit to this test where we want to test a single service. We could have just been using JUnit and Mockito. So when it comes to testing, to consider, is it worth starting the entire context? Is there any benefit? Are we writing an integration test that talks through our entire layer, or are we just interested in a single piece of our application? And when it's such a single piece, we are better off backing off any Spring Boot testing support, especially at Spring Boot test, because this is quite a big annotation that starts everything, whereas when we're just interested in a single service, we could have just used JUnit and Mockito. So there are cases where, in this example, for a simple service that doesn't talk to a database, for example, or doesn't reach out over the network or read something from a message queue, there are cases where a unit test is not sufficient, or a unit test wouldn't give us the confidence we could get when using a different testing technique. And this is my next point of the agenda of the things I wish I knew when I started testing Spring Boot applications. And this is slicing. So A classic Spring Boot application somehow consists of various slices. So we have a web layer where usually our API endpoints are exposed. Then we have some service classes where our business logic is being done. We have some repositories, for example. We have a data beans, and usually some HTTP clients. So taking a look at this, we can see there are various slices of our application that we can test in isolation. And what Spring Boot now adds to the table is support for testing the various slices of our application isolation. So taking the example of our web layer, independent of what technology we are using, so may it be a reactive endpoint or a classic servlet MVC endpoint or a GraphQL, there is a Spring Boot test slice annotation available that helps us test these layers in isolation. So what this annotation does, it will now create a much smaller application context just for this test. So when testing our web layer, we are not interested in any data repository. We are not interested in an HTTP client being populated because we want to test our web layer in isolation. And when it comes to the web layer, the beans that we are interested in this particular case is for sure our web controller. This needs to be part of the minimal context. Any filters, any converters, or also our Spring security configuration. This is these are the required beans that we need for testing our web layer in isolation. We then still, as our web controller usually depends on a service class to do its work, have to find a way around this. So either provide a dummy or use mockbean to mock any collaborator of this web controller, but now have a way more smaller context that Spring needs to start, which is much more faster while having a lot of benefits. We will see here a sample sliced test for a sample customer controller. The implementation doesn't matter. What's important is the way we set it up. So when using @MVC test, we can either specify a single controller that should be put into the application context, or if we don't specify a controller class, Spring Boot will populate all our controllers. This helps us to test our controller in isolation. We also get mock MVC auto-configured. Mock MVC is a mocked servlet environment that helps us test with HTTP-like semantics. So there is no HTTP communication going on, but we still have a lot more benefits compared to writing a single unit test, as we can now, for example, check HTTP response codes. We can make sure that our time leaf view gets properly rendered, make sure that any validation rules for HTTP post payload that gets passed to our controllers is validated, or any other HTTP semantics, for example, an exception being thrown gets mapped to the proper response code. All of this couldn't be tested with a simple unit test that just uses JUnit and Mockito, whereas with mock MVC we have HTTP-like semantics and can interact with this mocked servlet environment. Nice thing is that it also plays nicely with Spring security. So if we want to make sure that our authentication, authorization checks are properly in place, @web MVC tests work seamless with Spring security to then also make sure that, for example, an admin controller can be only accessed with a logged-in user having the role admin. So in an entire sample test of using or testing now a specific endpoint, we want to test API/customers endpoint to post some dummy JSON. You can see the first line, we have to mock any service that our controller interacts with, because for this controller tests, we are only interested in the HTTP semantics and stuff that is being done in our controller. Everything below the controller, any service layer, we are not interested when writing this test. So we can mock and predefine the behavior of the service that our controller interacts with. and then use this mock MVC instance, so it's like a client to interact with the mocked servlet environment. We can specify the HTTP method that we now want to test. This is now an HTTP post. The endpoint we want to test, we can now set the HTTP headers, so HTTP-like semantics, and then also add the actual content that gets being posted to the endpoint, and then after the processing happens, we can verify HTTP status codes, or in this example, following REST API best practices after posting a new customer, we are assuming that the location header is part of the response, and also have then here some kind of contract tests. So if we really specify here the raw JSON payload, we are going to make sure that we are using underscores and nobody changes it to camel case, resulting in a potential break of our API, while having tested it against a really small application context and not against an entire Spring Boot application context while using @webMVC test. So this was just an example for the web layer. There are much more test slices that help us test various parts of our application in isolation. So I would assume there's something available for all of your tech stacks. So we have something to test our HTTP clients. The REST client test lets us simplify the way we test HTTP clients by stubbing HTTP responses and then making sure our serialization logic or any pagination logic that we have implemented is properly working. If we have some JSON serialization logic that is custom, we can use @JSON test to make sure our object mapper serializes or deserializes our data structures properly. There is something available for most of the persistence technology. So there's @data Cassandra test, which will only populate relevant beans in the application context that are required for testing anything that talks to Cassandra. JDBC test, SQS test, this is kind of new, so also libraries are picking up this SQS test. Is if you're using Spring Cloud AWS, this helps or lets you test your message listeners in isolation. So you can then put something into a queue, make sure the serialization works, and any processing logic that you want to verify. All in all, there are a lot of these annotations. They're available and also explained in the documentation. You can even write your own. So if you're using a technology that is not covered by any of these Spring Boot test slices, you can write it. For example, if you're using Kafka or any other message listener, you can write these annotations, share them inside your company, and help your teams test your code in isolation without having to start an entire application context with @Spring Boot test. The last thing I wish I knew when I started testing Spring Boot applications is a more practical hint, or at least is about the JUnit 4 versus JUnit 5 pitfall. So when it comes to these two testing library versions, what we have to understand that JUnit 5 is an entire redesign of JUnit 4 and the next generation of it. Even though it was JUnit 5 was released in 2017, I'm still working with clients migrating from JUnit 4 to JUnit 5, or teams working with JUnit 4 being not aware that there is a new version. The pitfall that lies in here is that we can't mix those two library versions within the same tests. So if we are using JUnit 4 annotations together with JUnit 5 annotations within the same test, we will find results that we are not expecting. At least I and some team members of me have been in a lot of rabbit holes trying to understand why the test is not working, while we were copy-pasting, like it usually always is, stuff from either Stack Overflow, from other projects, not checking which JUnit version was used, or copying stuff over from blog articles. What we can do if we don't have the time to migrate our entire JUnit 4 or even JUnit 3 test base to a recent JUnit version, we can run them next to each other. So it's fine to use JUnit 4 for a single test class, but we can't mix JUnit 4 and JUnit 5 within the same test class. If you're looking for support to migrate JUnit 4 to JUnit 5, I can highly recommend to check out Open Rewrite. It's an open source tool to automatically migrate, for example, from JUnit 4 to JUnit 5 without much intervenence on our own. As a small cheat sheet to understand when you're using which JUnit 4 version, here are the most important annotations that differ. So when it comes to add test, the annotation is the same, and if you don't, if you're not fully aware what you're doing when implementing the test and just hit autocomplete inside IntelliJ, you might pull in the wrong import and then end up running your test with JUnit 4 while you thought you were using JUnit 5, and then ending up with a result you were not expecting. When it comes to extensions, so JUnit 5 uses extensions, whereas with JUnit 4 we had the rule API, so they are not compatible with each other. So whenever you see add run with in various blog articles, Stack Overflow examples, or also older code base of yours, you will know this is JUnit 4. When it comes to JUnit 5, these rule API is no longer present and got replaced with the extension model. So there it's the extend with or register extension. Where it becomes less obvious is for the lifecycle methods, where you can have lifecycle callbacks for your tests to set up data or to clean up data. With JUnit 4 it's before, and with JUnit 5 it's before each. So a single word changes the JUnit version, which can be overseen quite simple if you're not paying full attention while implementing, ending up in a rabbit hole and running your tests, not trying to understand why Spring Boot isn't able to load your context, or any custom extension is not fully loaded. So some words on where to go next. So given the minimum time I had, these were just the 4 things I wish I knew when I started testing Spring Boot applications as a beginner. I know there is way more to testing Spring Boot applications, but at least those are the fundamentals. I wish someone would have told me when starting testing Spring Boot applications. What I can give you as a hint is to get familiar with the slice test context annotations. I guess this is quite unique for a test setup, that we are able to slice a specific part of our application context and then test only against a minimal subset of the annotation. Another more practical recommendation is align the test strategy and vocabulary in your project. So I've been to tests where there's a lot of religious discussion. Is this now a component test, an integration test? Should we call it unit test? Where is the boundary? So to make things simple, I usually like to either define it with some single sentence or give an example to not end up in discussions and saving precious time to implement tests and not figuring out what's the correct testing term for this. In general, it always helps to understand Spring Boot's auto-configuration mechanism. So when I started using Spring Boot, I for sure called it at least 1 year magic, as most of us, I guess, do. I wasn't aware what's going on under the hood, but if you really take the time to see what's going on, how smart the framework tries to detect what you need, what to auto-configure, it will also help you with your testing efforts, because then you understand the test slice annotations, can properly understand the error messages as you understand which part isn't auto-configured for this particular test now. In general, I'm not a religious advocate, but I can really recommend giving test-driven development a try. For me, really the breakthrough was when I really understood what Spring Boot offers when it comes to testing, when I understood the entire Java testing ecosystem. So the Java testing ecosystem is huge. There are a lot of frameworks to be learned, to be used, which is additional knowledge you need, and maybe not the nicest thing to learn when you want to implement shiny new features. But as soon as I had a a set of recipes or knew how to test, for example, an HTTP client, how to handle repositories. Really, the test-driven development gave me even more confidence as I start the implementation with test-first mindset. If you're entirely new when it comes to testing, I would recommend starting with the fundamentals. So start with understanding JUnit 4 and Mockito, and only then explore further excellent Java testing libraries like test containers, for example, wiremock for mocking HTTP responses, or Selenide, which is a small wrapper on top of Selenium to write end-to-end tests with ease. So if you're interested in a bit further content of me, as already mentioned, I'm also running some blogs and online courses on my website. I have an in-depth Spring Boot testing masterclass where I will teach you everything you need to know for testing your Spring Boot applications. It's a hands-on course, more than 10 hours of content. I've also written some books. You will find the links below. The books are distributed via LeanPub, where I, as mentioned, talk about Spring Boot and AWS. I also have a small book where I introduce the various Java testing tools in the cookbook-like style for you to understand when to use which tool. And last but not least, we can go to the conclusion of the talk. All in all, Spring Boot provides a lot of excellent testing tools and really emphasizes testing. So the development team of Spring Boot really made sure that we as a developer don't have a hard time testing our applications. Every Spring Boot project, you might not have recognized it, comes with this fundamental testing toolbox from day one. So there is no discussion required. We can just get started with writing our tests. Whenever you write a test, ask yourself, do I really need to start the entire context for this particular test? If you're testing a smaller service in isolation, there is no need to start the entire Spring Boot context. If you're testing somewhat not so obvious parts of your application, for example, a custom native SQL query, you want to for sure interact somehow with a database, then you are fine to use a slice context. In general, I keep at Spring Boot test reserved for integration tests and don't spread it across the entire application for various reasons. The main one is that it really slows down the feedback cycles, as starting an entire context multiple times takes a lot of time. Yeah, and slice context we covered, and the former one, again, when copying stuff, especially for testing, make sure you match the correct JUnit version that is used for your project or this particular test class, as this will save you quite some time. And all in all, have fun writing your tests. It doesn't have to be an afterthought. So once you are familiar with the tooling, understand when to use which tool, you will have a great time writing your tests. So after the talk, please, I guess as most of the speakers already mentioned, take your survey to give me feedback for the talk. And taking a look at the time, I guess it's lunchtime now. Thank you very much for listening to my talk, and see you around.